let me open this can of beer first. We don't want that recorded.
It's recording, but the webinar is not started yet, so we can edit this out.
You've got to opt in to be recorded too, Frank.
All right, ready? 3. All good?
Just
3,
do it.
2, 1, going.
Wait. All right.
We should have had some elevator music or something to start this thing. I didn't think about that.
Little Jeopardy theme song.
How's it out west, Frank? On the ranch?
Pretty good. The cattle are heading down for the high country. Starting to snow up there. You know, the rattlesnakes are all denned up, so that's good. Lower the objective risk a bit for everybody. The coy dogs, oh boy, gotta watch the calves. Still a couple second round of calves that just came around. Coy dogs are getting after it.
Where is that background picture? Just random?
No, that's actually Paradise Valley,
Yeah, nice.
along the south of like Prairie, Montana, just southeast of Bozeman.
Yep.
Like if you're going towards Yellowstone that way. I forget what river that is. Some good ice climbing up in there, and that was a really good dispersed camping night, though my hackles were up. This is the road trip a couple years ago. What hackles were up, there was a bear circling us. I ended up, it was a little spooky, but definitely smack dab in bear country along the Beartooth mountain range there. Have you been out there to that area?
Yeah, Yellowstone and that area, but not Paradise. I can't remember Paradise Valley. Looks pretty sweet.
Yeah. There's an old school spa resort there too, like a big there's a couple. I've been to one in California too, where it's essentially like a pool that they build around a hot spring that comes up out of the ground. And I'm really blanking on the name. Somebody in the audience could probably tell me, but they built a restaurant around it, and there's a bar, obviously, at this big public hot tub. You know, there's like hundreds of people in there, a restaurant, and
Chico Hot Springs.
Yeah. That's the one, Chico, yeah. Pretty, yeah. Mona got it. Chico, yeah, probably. Folks been there. Hard not to drive by that place.
So I know everybody wants to hear your home on the range stories, Frank, but I think maybe we can start to get going here. I'd like to thank everybody for coming and supporting this joint effort between the Mount Washington Avalanche Center, the White Mountain Avalanche Education Foundation, and our local backcountry community. This is our 11th event, 11th ESAW event. And every year, I think we continue to improve. And, this year, like last year, we decided to do a virtual event, and we tried to keep the costs low for everybody so that this is an educational opportunity that's accessible to a lot of people. And, I want you to know that the money that is made from this event does go to the Avalanche Center and to the kind of 3 main operational areas, which are avalanche forecasting, search and rescue, and education and outreach. So your attendance of this event not only, I hope, will help you further your knowledge of avalanches and snow science, but it's also a huge a huge support to the Avalanche Center up here. So before I introduce our first speaker, I'd just like to give a shout out to our headlining sponsors tonight, American Avalanche Association, DPS Skis, Patagonia, and Tuckerman Brewing. And we have a few other sponsors that we'd like to mention as well that are also part of our raffle that we will have some sweet items to give out tonight. Acadia Mountain Guides, who's been a longtime supporter of the Avalanche Center, and Esau, Ski the Whites, Ski Shop in Jackson, Hillary McCloy, Physical Therapy. Thank you all so much for your support. So we have two headlining speakers tonight. One of them is Doug Workman. But before I introduce those two gentlemen, I'm going to introduce Frank Karras, the director of the Mount Washington Avalanche Center. And Frank will be giving a tribute to the late Brad Ray. So if you're ready, Frank, take it away.
All right, great. Thanks, Pat. Welcome everybody to the 11th annual SAW here in the East. I just wanted to say a couple words. I think some of you folks joining have been around skiing in Tuckerman's probably longer than I have. And you may have recognized a gentleman who passed away recently, Brad Ray. You may have heard that news. It was interesting to know that he was the second director of the Avalanche Center since 1954. I'm just the fourth, but he was there for almost 45 years. And no doubt talked to a lot of folks. And he certainly helped a lot of folks who had gotten into trouble, needing rescue or medical assistance. So he passed just recently and made a strong impact on a lot of people, including me. And he will be missed, though his legacy lives on through a bunch of us in the ski patrol, as well as snow rangers that knew him, or even just like me, heard lots of stories about him. So I don't want to belabor that point too much. I think everybody's ready to hear about some snow and avalanche topics tonight. I believe John Sharaf up next. Some of you may know he's rejoining us again to deliver a topic on crusts and facets. I'll let him talk about his actual title, but Don does have quite a depth of experience in the avalanche world and is a co-owner of American Avalanche Institute and started out a while ago as a Hermit Lake caretaker. And a lot of folks don't know that. And so he does have that experience with crusts and facets as well. So take it away, Don.
Great, thank you. Let me get the right thing up here. Hopefully it's gonna play nice. Yeah, there we go. All right, thanks for the invite. When Frank gave me the call to present here, I was psyched. And then when he said, well, I'd like you to talk about crust and facets. And I was like, wow, everyone's favorite ski conditions. So, all right, that's going to get everyone pretty psyched. I realized as I was doing this that I don't take a lot of video when I'm on crust and ice and facets. So this is going to be strictly a bunch of pictures and a bunch of stories. But it's not unique to New Hampshire. We get plenty of facet crust combos out in the West as well as up in Alaska. So don't feel like you're the only ones who suffer through bad snow. So I was wondering, well, you know, does this really, if you're thinking, does this really apply to you? This is a quote from one of the avalanche advisories from last year. And it struck me that knife hard refrozen crust from the 157-mile-per-hour wind event. I was like, wow, that kind of sounds like Iceland actually. But yeah, it's certainly not a unique event in your neck of the woods. And sometimes the layers above and below are facets and sometimes they're not. But we're going to talk about basically how different crusts form, how the difference between crust and ice, talk about how facets form in general, and then look at that in particular around crusts. And then I'll tell some stories, talk about some case studies, try and pull it together at the end, and also give you some tactics for the season. So that's the general flow of this talk. So off we go with crusts. So rain crusts, no mystery here. Basically, when it rains, you start impacting the snow surface, and the more it rains, the more that snow surface gets saturated, and it can penetrate down. And I've seen rain crusts in the Northwest that have been more than 1 meter thick. So you can commiserate with the Northwest there for sure. But what is significant is until that liquid water refreezes, until that becomes ice, that temperature with the water soaked snow is 0 Celsius. It's the only temperature that it can be, or 32 Fahrenheit. It's known as the triple point, where you can have vapor, liquid, and solids coexisting. So it's going to be as warm as snow can be. But once you have sustained cooler temperatures, probably some clear skies, then that freezes up into the rain crust. And when you think about the different crusts that can form, think about where they're going to live. And for rain crusts, they're going to be very elevationally dependent, meaning that they are probably going to live where it was raining and then got clear, and it may live kind of in this middle zone where it rained a bit and then it finished with snow, and they may not live up high where it didn't rain at all. So those rain crusts are really driven by elevation, but not by aspect. You're going to see them on all faces of the compass, if you will. So for a rain crust, elevation dependent. For ice, I'm not sure why I skipped it here, but for ice, we're talking about a solid layer that you can't break apart into individual components. Like it's essentially just a translucent layer. And here we have basically pure ice, looks like a crust, but it's functionally ice. And then you have these percolation columns extending vertically that they're all ice forms. So that's the difference between crust and ice. You can't break it apart into individual grains, and it's ice hard. It's not even knife hard. You can't put a knife through it. So sometimes you see these ice lenses form with really light rain, and often on a cold, very small grain surface like a wind slab, and you can see this crust develop that we have occasionally called in the Tetons the pond ice layer, because it's basically like something you could skate on. So that's an ice crust. Sun crusts form because of incoming solar radiation, and they're going to be very much aspect dependent where the sun is hit. But they're also going to be angle dependent, and that might become a little clearer when you think about the angle of the slope. So even in the dark part of the winter, December, if your slope angle is very low, the incoming solar radiation is going to reflect quite a bit. But if your slope angle is higher, the incoming solar radiation is actually going to reflect less. It's going to absorb more heat. So you can develop crusts or sun crusts on higher angle slopes, even midwinter or early winter, if they're directly incident to the sun's angle coming in. So sun crusts are aspect and angle dependent. Rime crust is kind of a special case. If you look at this ridge line, you can see right in here that there's a cornice. So this side is typically the windward side, and with rime formation, you have super cold liquid water. It's looking for something to freeze onto. And when it hits a chairlift tower or the side of the Mount Washington Observatory or a snow slope, it's going to instantly freeze, go from this kind of super cooled liquid water just to a frozen glob of water. And if it happens over time, you can develop these very slick, shiny rime crusts. And certainly out west, these things are responsible for major avalanche cycles and prolonged weakness. They're very persistent. And we often see these things around for a month or two. And this one, in fact, was a month after it formed, and all the snow kept getting stripped by the wind on this windward side and then being deposited on the leeward side. And that was a problem for quite a while. The rime crust, because it's forming into the wind, tends to be more pronounced on these windward aspects than on the leeward. All right. So facets and depth wear, I'm not going to dive into depth wear too much, just explain that it is kind of the end result of a long faceting regime. But we'll talk about the different ways that the snowpack can change due to faceting or strong temperature gradients. I realize that some of this may be brand new for a lot of you, and that's a good teaser for you to take a level 1 avalanche course. This is stuff you'll learn about, or it may be a good review for those of you who've been learning about this for a while. So here we go. Basically, in order for faceting to occur, you need a strong temperature difference over a certain distance. So we typically talk about a temperature difference of 1 degree Celsius over 10 centimeters or greater, causing a transfer of vapor from warm areas to cold areas. And you can think of those warm areas as ground, but in several instances, we'll create another warm layer near the surface of the snowpack as well. So what's happening is that vapor in the snowpack is moving up from that warm area. And if it finds something that's frozen in the way of it, it's going to deposit from vapor to ice. And it does that in hexagonal symmetry, perfect 120-degree bonds or angles, and it creates these sharper faces. And over time, these things can build up. The crystal gets a little larger over time as it facets and continues more. And it is robbing moisture or vapor from the top of the crystal. So typically we see the bottom of the crystal becoming more angular and the top not quite as angular. The things that make this go faster is a high temperature gradient, meaning a bigger temperature difference over a set distance. So bigger number of degrees different from bottom to top. And absolute temperature, the colder it is, generally the greater the gradient. And the pore spaces. For various reasons, low density snow tends to facet more rapidly than higher density snow. So new snow that came in without wind will likely facet out faster than a really well cemented wind slab. So this whole process could start with some new snow or settled snow or even rounds. And if you have a strong enough gradient over time, you're going to start seeing more angles appear on the grains. But even more importantly, you're going to start seeing the bonds between adjacent grains decay. And what the problem with facets is that all the connections are really top and bottom, because that's where the vapor is moving up, depositing, and your predominant connections are top and bottom. So that makes these layers strong enough in compression to support more snow, but not strong if they break in shear, meaning a sideways motion, then they all fall apart as a unit. So It's not just that they're getting bigger and sharper, but it's because those bonds are decaying. And then if it goes on long enough, you start seeing stripes or striations on the grains, on the facets. And if it goes on even longer, then you see these cup-shaped crystals that we call depth hoar develop. It is rare when you're not near the ground that you'll see depth hoar developing around a crust. Usually it's some version of faceted snow. So this is a really quick summary of the different ways you can generate warm and cold layers in the snowpack. So if you have a shallow snowpack, say if it was only this deep, you'd have the ground at 0 Celsius because it absorbs heat through the summer and then re-radiates it through the winter. It's typically around 0 Celsius. And then you have a shallow snowpack and cold air temperatures. And you see the bottom of the snowpack rotting out. This is the story almost every year out in Colorado. And it's a common problem. Not as common, I feel, in Mount Washington. So that's the typical way we think about facets developing. But what if we have a near surface warm layer and then shallow snow over that? That's another way we can create faceting. So there's 3 of these near surface faceting mechanisms. I'm going to talk about 2 of those. So diurnal recrystallization. So during the night, the snowpack typically gives up heat in the form of infrared radiation, and basically it cools the snow surface. And so you have a gradient where you have warmer snow, 10, 20 centimeters into the snowpack, very cold temperatures at the top. So you have a faceting gradient at night. During the day, that can actually flip-flop, and you have incoming radiation coming in, it warming the snow surface more than 10 to 20 centimeters down. So your gradient actually reverses. 20 centimeters down, there's not much temperature change throughout the day, but the top 10 centimeters are going through this big temperature swing from day to night, and that often creates facets. That alone wouldn't be, it's not that common a scenario in the White Mountains. But think of this. You have a rainstorm, gets on top of the snowpack, then freezes into a crust. And then, days, even a week later, you get a little bit of snow on top of that. And then it just stays kind of cold and clear. Nothing much is happening. If you don't have wind blowing it hither and yon, which I know is kind of a tall order, then that snow is probably going to become faceted, and then you're going to have weak snow overlying a crust. So you're creating this bed surface and weak layer setup, which putting more snow on would be a problem. So that's one way to get facets around a crust. Another common way to get that warm layer introduced is you have sun or rain, most commonly rain, warming up the snow surface. And again, I said, as long as there's liquid water, that's going to be at 0 Celsius. So what if that warm layer quickly gets buried by another layer of snow? And typically, 5 to 10 centimeters, 2 to 4 inches of snow is kind of the ideal situation for this, where after the snowfall stops and you have cold air conditions, then you have a really strong gradient between warm, the rain saturated snow, and cold. And until that rain liquid water converts to ice, it freezes into ice, you're setting up a really strong gradient, potentially in a very thin layer of snow. So that's how facets develop within that near surface layer, or around that crust, I should say, and predominantly in this case, above the crust. Okay, so that's 2 of the 3. You can see in this picture from Juneau, Alaska, that we had rain down low and we had pretty good snow up high, but this kind of bathtub ring in here of elevation is the zone that I'd be worried about melt layer recrystallization happening, because it had rain during the storm and that was followed by snow at the very end of the storm. So you have kind of a setup for melt layer recrystallization in this narrowly defined band of snow. So this is going to be an elevationally driven problem. I will just say that there's a third mechanism for near surface fastening that you probably don't have to worry about in the whites because of the lower elevation. But if you're curious, we can talk about this after the talk, but this is the third mechanism for weakening the snow. Okay, take a breather for a second. Now there's some good new research that has come about talking about faceting around crust. So we're not talking just about the faceting when that layer was warm, but we're talking about what if this crust is well buried in the snowpack and you don't have a super significant gradient from a layer buried saturated snow, water saturated snow, but you're just looking at the impedance of the crust to vapor. A common thing when you pull out a crust is that you will see facets, these sharp square crystals forming, and quite often I see them well developed below the crust, sometimes above the crust. So how is that happening when it's deep in the snowpack? So a few of you may find this a little tough, but I'm going to try and bring it around so that it makes sense. It's a concept of thermal conductivity. So if you think about the transfer of heat, if you're just outside in the air and not touching anything, you're going to get in cold air. You're going to get cold, but at a relatively slow rate. If you lie down in snow, the thermal conductivity of the snow is going to get you colder about 10 times faster, because the snow is has 10 times the thermal conductivity of heat than dry air does. Ice actually has about 10 times the thermal conductivity of snow. So what that means is that if you have buried ice or even crust within your snowpack, your temperature gradient is probably going to be pretty low actually through that crust layer, because it conducts heat so well. So if we're looking at temperatures down low of 0, -1, getting progressively colder through the snowpack, then there's this really this discontinuity as you hit the ice lands or the crust, because it conducts heat so well. And then you see another stronger gradient as you leave. So the net effect of that, because of porosity decreasing as you hit the ice lands below it, is that you have deposition of vapor on the bottom. So you're depositing vapor into solid. So you're creating, that's one way to create facets. And above that lens, you're seeing the porosity increasing and the ice lens are actually giving up vapor to crystals above it. So sublimation is occurring. So part of this, the net result is that faceting can continue because of this accentuated gradient around the crust for quite a while, even if your thermometers tell you you have a gradient that's not conducive to faceting. It's not greater than 1 degree Celsius per 10 centimeters. Okay. So that was the theory. In the cold lab, Kevin Hammond's actually measured this, and he's kind of a smart dude. He's got built into the sample basically these micro thermocouples that were able to take temperatures on the millimeter scale. And just a way to grasp that, look at the your fingernail on edge. And then 1 millimeter is about 3 of those fingernail thicknesses, if you will. So we're looking at really, really fine measurements here. So what he found in these samples that he had in the cold lab, where he induced a temperature gradient, was if you just measured every few millimeters, you would see a temperature gradient like this blue line, what you would expect. But with the thermocouples, he was actually able to measure it on the sub-millimeter scale. And what he did was he broke out this area, and that's what this graph is right here. So we're looking at a 4 millimeter thick ice lens, and then within 1 millimeter on either side, and again, we're talking about 3 thicknesses of your fingernail for scale, you have a really strong temperature gradient near that crust. And the reasons for that are multi-fold, but what the net result is that your dial stem thermometers are not going to be able to pick up these micro scale gradients. But the net effect is that you're getting really strong gradients, creating really sharp square crystals on either side of the ice lens or the crust. In these faceted crystals, it happens about twice as fast on the bottom boundary of the crust as it does on the top boundary. So the short version of this research is it confirms that pretty much your stability test and your lens are better tools for identifying faceting around a crust than thermometers are. So you can throw that thing away. Tell them I told you to. Another part of the study, or another study, was Bruce Jameson looking at 74 different avalanches that occurred on crusts in the Columbia Mountains in Canada. And what he found was the average age for new snow, precip particles, and decomposing fragmented was around 2 to 3 days, with maybe an outlier of 6 days. So didn't last long. You know, if you had new snow over a crust or wind-broken particles over a crust, yes, it could avalanche, and yes, it has avalanched, but it didn't last very long before it stabilized. With surface hoar over a crust, you have a median age of about 11 days, but in some outliers out to 30, 32 days. But in general, doesn't last as long as faceted crystals depth hoar around a crust. And this median around 20 is significant, but the outliers, 70 days out, those are the ones that really catch you off guard. And we'll talk about a case where that happened in your neck of the woods, actually. So sum up that study. Smaller facets tend to bond more quickly than larger facets. Melt layer recrystallization can be limited to a very narrow band of elevation. 94% of avalanches that ran on crust were failing on persistent weak layer types. So it doesn't mean that you can discount fresh new snow over a crust, but that's going to stabilize relatively quickly. Persistent grain types like surface hoar or facets last a lot longer, and that's why we call them persistent. And then most of the facet layers associated with the crust are thin. So about 60% or less than an inch thick, less than 2 centimeters thick. Okay. Science is over. I'm going to tell some stories. So this is a study from Scotty Sowage, and he did a study on deep slab avalanches at Big Sky ski area in Montana. And Lone Peak is 11,000 feet. It's taller, it's 1,000 feet taller than anything else around. It's really windy, really cold. It's like Mount Washington with 5,000 more feet of vertical. So that's kind of the climate that you're dealing with. He defined deep slabs as crowns greater than 1.2 meters or 4 feet. He had 74 different avalanches between 95 and 2006 when he did this talk, and some in varying amounts of ski compaction. So this is open terrain eventually, typically on the south face of Lone Peak. And he addressed a number of things, but I'll talk about the weak layer and the bed surfaces now. So for the bed surfaces for these deep slabs, they were 100% crust or ice. Okay, so that's telling in of itself. You know, crust and ice make good bed surfaces. That shouldn't actually be very surprising, but 100% of them, that's a little surprising. For the weak layers, he found some interesting things. Typically, they were very thin, less than 1 centimeter, often as thin as half a centimeter thick. So not very thick at all. We're looking at less than half an inch thick. Less than a quarter inch thick, sorry. They're typically composed of small facets, which were most often formed by near surface fastening processes. For that place, I would say probably most often diurnal fastening of snow that fell onto a crust. Depth hoar was not a common weak layer, and the thought on that is that depth hoar is weak enough that it would often avalanche before it reached that critical 1.2 meter cutoff. So it wasn't actually a common weak layer with these deep slabs. A fascinating thing was that in the crowns, there were some interfaces with no obvious facets. It was just a really hard surface with what usually would be a strong bond, but if you build a slab on it fast enough and heavy enough, it can avalanche without any obvious weak layer. And the sad thing about these hard crusts is they set up for repeat events, because if it avalanches out on a bed surface of crust or ice, that remains. It doesn't get changed or wiped out. Get a little bit of snow that can then diurnally facet again. You're setting yourself up for a repeat offender that season. Okay, so the common snowpack scenario, and this shouldn't sound too unfamiliar to all of you on the East Coast. Early season snowfall, bunch of wind, and then there was a clear and warm spell or a rain event. And often for their season setup, they're looking at this happening in October into early November. And then what they end up with is a hard ice layer anywhere from 30 to 40 centimeters above the ground. That takes out a lot of the surface ground roughness and creates a good sliding surface for future avalanches. So that's a good synopsis of how you can get really big avalanches with facets and crusts, or just crusts. Moving a little further south into the Tetons, in December 2008, we had a really widespread, long-lived cycle on facets around a crust, or actually around two crusts. And you can see from this photo, there's a lot going on here. You have the avalanche of the hanging snowfield up here. And then you can see a snowcat triggered avalanche in here, and then an explosively triggered avalanche from a day or two prior down in here. I think that might be Laramie Bowl. Anyway, yeah, a lot going on in this, and obviously a really weak setup for a lot of snow. So how'd that happen? We had, in early November, we had about 30 inches of snow, reasonably seasonable temperatures, nothing too cold during that time. One big dump, but generally just building the snowpack so that the snow depth at that point was about 19 inches, 21 inches. So what is that? Just about 50 centimeters deep. And that was at that point pretty darn good. Unfortunately, the storm ended with rain at 10,500 feet. And so we had rain saturated snow up to the very top of Jackson Ski Resort, well into the Alpine for the bigger peaks and the Tetons. And that capped off all that snow. Then for the rest of November, didn't get very much snow. We actually had 6 inches of snow in 15 days. Temperatures that got pretty warm for a little while, but stayed generally below freezing for a lot of the time. So that snow sat on top, it wasn't much. And for the areas in the shade, they tended to facet up on top of a crust. And then we had another rain event that put rain up to 9,000 feet towards the end of the month. So December, not much was going on. We had some clear days that gave us surface ore and near surface faceting on the surface, relatively cool temperatures. And then the snow just started gradually coming in. Nothing too fast, nothing to make a big slab very quickly until we got into the 21st. So for that period, 21 inches of snow, and that's including the 10 inches over here, I believe. So not a lot of snow over 10 days. Then the fire hose came on. So we had, as you remember, we had one crust of 10.5. We had a little bit of snow in between that faceted, another crust of 9,000 feet. And then this 20 inches of snow gradually building, and then the fire hose turned on. So I'm going to tell you about events on the 24th, the 27th, and the 29th. Pretty strong winds during that period from the west and the southwest. Cold temperatures, but rising temperatures up to the 29th. And you'll see why that's significant in a minute. So on December 24th, the backcountry guides at the ski area were going out to check out their out of bounds terrain, and they were boot packing basically just in the trees behind where you can see in this photo. And they felt a big whoomp or collapse, and they saw an avalanche moving down slope, and then they went over to investigate what had happened. And what it was the the mid-November rain crust, which had facets and surface ore and facets over it, basically avalanching it. This is where it broke right underneath. So this is the snow that built up gradually, and then this is the last 3 or 4 days of snow that came in on top of it. So we're getting widespread collapsing or whooping that day. There was other avalanche activity, but this was one that they triggered on a slope that they weren't actually directly on. So the remote trigger, very weak snowpack. And that was the start of a very, very big and long avalanche cycle. 3 days later, David Nodine fortunately perished in an inbounds avalanche when they just opened for that chunk of terrain for the first time that season. That involved a very well-coordinated rescue, but it wasn't enough in time to get him out alive, sadly. And then another 2 days following that, many of you probably heard about the restaurant at the top of the gondola getting hit by an avalanche. This was pretty significant avalanche, and definitely impacted operations in a number of ways, including making it a lot harder to get a meal. Sorry, there we go. So that's the inside of the restaurant after it blew out the back windows. That's quite the event in itself, but basically that facet crust combo was responsible for upwards of 70 different reported avalanches and countless more that we didn't hear about. This is not playing nice. The last story before I start getting into your neighborhood is from Alaska. This is the Avalanche. This is the one that dammed the low river and backed it all up. Basically, it was 6 inches of rain, saturating a pretty unstable snowpack, and we had massive avalanches. This was largely explosively triggered, but there were also some naturals incorporated in this. But that wasn't the bad part of the story for us as a heli ski operation. That was basically just the setup. What happened was this storm at the beginning of January 2014 created a saturated wet layer on the surface where it didn't avalanche. And then the storm ended at least above 2,500 feet with snow, and just a bit of snow. And that snow then sat in -20 air temperatures for 2 weeks. So that thin layer of snow over a very thick layer of saturated snowpack faceted to the extreme. It's the only time I've ever seen depth hoar grow on top of a 2-meter snowpack. And that was very, very rare and unique, I would say. As that layer started getting buried, as our heli season started, we started seeing more and more avalanches. And this was triggered by some of our guides coming up this bench. And you can see all the slopes where they got a collapse here that avalanche there, and up to 400 meters away, all along these slopes that were just steep enough to slide, including this one. So we were setting up for a big cycle. We had a very weak crust facet combo formed by melt layer recrystallization. And we did see quite a few avalanche events. Fortunately, the snows came in relatively slowly, so it gradually gained some strength instead of one big snow event that gave us what we were hoping for, a crush and flush cycle, and it didn't quite happen. But that, boy, this is not skipping well. The biggest avalanche that we encountered was a ski triggered avalanche about a month and a half after that layer was buried, and it did take out quite a significant chunk of terrain. So the last avalanches on that layer became quite stable for a while, but during the spring warm up, when the slab lost strength, there were some avalanches that went all the way down to that Avalanche layer. Okay. So I'm going to talk about 3 notable events from your neighborhood. This is, you may recall, April 11th, 2019. This is Raymond Cataract. And as I understand the story, a skier was skiing solo, came down and triggered this avalanche, and then it then channeled down Raymond Cataract, east side of Mount Washington, into a train trap and piled in very deeply, burying that skier. Some people noticed the debris or the crown, reported it, and Frank can certainly tell you more about the story, but he came out and dug out the victim, who was initially alive, but succumbed to the burial eventually. So this was a situation where we had a very hard crust layer and then a really rapid load. So it wasn't involving crust over facets over crust. This one was new snow over crust, some riming of the new snow, but you know, if this had lasted for a week without being triggered, it probably would have bonded up and been quite stable. It wasn't a persistent grain type, but this was hit very soon after that wind slab came in. So that was the nature of that avalanche. All right, this one, I believe, oh, that's the crown for that avalanche in Raymond Cataract. Okay, all right, back to this this past winter, February 1st, 2021. I was just reading about this, and this one may or may not have been associated with crust and facets, but it does show a commonality with the previous avalanche in the terrain choices and the travel technique. So this was a very experienced skier coming up Amanuset Ravine, and then was probably caught by a very small avalanche in this track. Unfortunately, this gully comes into a terrain trap, getting basically trapped by this rock wall in here. So it's that in itself may not have been that large an avalanche. The terrain trap definitely compounded it. Subsequently, before he was found, larger avalanches happened because of a bigger storm. So that ended up being a very, very deep burial, a 4-meter deep burial. The photos are quite impressive of the rescue effort, but it just shows you the nature of micro terrain features. This seemingly very small initial avalanche was compounded by the terrain trap, and the lack of partner. So no chance of rescue there, or companion rescue there. All right. And then finally, this is March 29th, 2014, the southeast snowfields off the summit. I think I've skipped some pictures here. That gives you the scale of it. A 1 meter to maybe 1.4, 140 centimeter crown. So pretty deep, 3 feet, 4.5 feet. And really a large deposition area. And this one was on a layer that was formed, a crust that was formed on January 11th, with small grain facets developing above that. And that led to a combo that avalanched on steeper slopes earlier. So there were some avalanches in Tuckermans and Huntington that came off because it was a pretty weak combo, but they happened months earlier. This is a pretty stubborn angle. I think if I remember correctly, it's around a 32-degree slope, not very steep as far as avalanches go. So it was able to build this slab over time, pretty continuous one. And basically avalanche, what was it, roughly 77 days after that weak layer was formed. So again, this is not the Raymond Cataract avalanche that was 2 days after this slab came in. This slab formed over 77 days. So that's quite a difference between the grain types sitting on that crust. Okay. So sum up, crust, red light conditions you need to look out for are facets that are on either side of the crust. And I would say that your best tool is to dig down to this crust and look at the grain types associated with them. Look for those sharp edges. See if they propagate in the extended column test. That's probably your best way of assessing those, whether that crust is a problem or not. You'll find the crust very easily with your ice axe or maybe your ski pole turned upside down, but you may not be able to find whether the facets are developed around it or not without digging. Anytime I find really slick crust, really smooth crusts like rain crust, rime crust, less so sun crusts, that's going to be harder for snow to bond to. So the rime crust in particular really keep my attention. When you have really uniform crusts that cover a large amount of territory, those are capable of producing larger avalanches than if you have just, it's kind of spotty and broken up in thickness and just extent. So that's something to look out for. All right. And then anytime you have a crust and you get some snowfall on top of it, and then it goes high and dry in cold temperatures, you can see that new snow that's just a thin layer fastening relatively quickly. And again, this is going to happen faster if it's low density snow as opposed to a wind slab blown on top. So that's, I would say that's probably a saving grace of the winds on Mount Washington, is it kind of keeps that from happening very often. Okay. When are crusts good? Well, never when you're skiing on them, but if they're super rough, it tends to make it easier for snow to bond to them. When they're pretty variable, you know, you have it in some areas and not others, it could lead to very small pockety slabs, but at least it's not going to encourage the really widespread larger D3 avalanches. And then at a certain point, when can you lock down those lower layers and not be worried about them? And that's always been a question I've asked a lot of people. It's like, how thick is thick enough to lock this down? My experience is if it's 20 centimeters, 8 inches or more, tends to lock down what's underneath it. Typically, as you go up in elevation, those crusts will tend to thin out. So you're still might be something to consider, but it's definitely something I do pay attention to. All right, about done. What can you do about it? I think it's super good to follow the forecast. I would imagine that all of you tuned in tonight are people who look at the forecast, but don't just look at the latest one. Go back a week, so that you have a sense of what's been the kind of the pattern up to this point. There is also the potential for a bit of message fatigue. If a forecaster has been talking about the same problem, nothing's been happening on it, then that may they may be reluctant to keep talking about it. So just be aware, it's good to know more than just your latest forecast. So anticipate your problems, follow the weather and season history. If you're not there, keep tabs on the forecast, but also if you have the time, look at the obs from the summit, look at the obs from Hermit Lake, and anticipate, oh yeah, rain event, okay, it looks like it ended with snow. Oh, we might have the setup for melt layer recrystallization, especially below tree line in non-winded areas. So anticipate those problems. Hopefully I gave you some tools to anticipate with. Then check out that bond in the field, either pushing your ice axe through the snow, digging down so you can push your ice axe lower, turn your ski pole upside down, pushing the handle in, or pulling out that shovel and actually doing extended column tests. Doing hand shears if the crust interface is within that realm that you can dig to with your hands. And then there are a few small test slopes around the east side of Mount Washington. It's sometimes hard to find ones that aren't consequential, but if you do, go ahead, jump on them, see how they're reacting. Are you getting collapsing? If you are, dig down and figure out what layer is giving you those whoops. Okay. And then speaking to the last two fatalities, be aware of the terrain that surrounds you. You know, even if you're in a limited start zone, if that small area piles into a terrain trap, that's going to be far more consequential. So always be cognizant of what you're above and what you're below. And have a partner. You know, it's hard to say for sure, but it's likely those last two fatalities in the presidentials may have had a different outcome with partners. So as experienced as you may be, and it sure sounded like that fellow in the Ammonoosuc Ravine was very, very experienced, you won't always be right. So have a backup. And then good habits are bad to break. I am frequently not right, but always traveling one at a time. I'm always thinking about my escape routes. I am almost always have a partner. So those good habits are what keeps me alive so far. All right. So thank you to mostly to all of you. People who posted their observations to the Avalanche Center. That was super helpful putting this presentation together. And I think you're painting a bigger picture than just the forecasters can give. So a lot of thanks to all of you. To the White Mountain Avalanche Center Education Fund, and then to all these folks for their pictures. And I'd like to finish. Thank you to Brad Ray. I had the opportunity and the pleasure to learn from him and Rennie LaRoche back in the late 80s. And I'll share one story that it still sticks with me is we're up digging a pit on the upper head wall, and he made a snowball and threw it down slope. So Tuckerman ran down chasing it. He's like, well, looks good for the 100-pound test. You should go next. So always think about your travel techniques and exposing one person at a time and who's going to be the test dummy. So thanks. And if there's time, I'll take any questions.
Thanks a ton, Don. That was awesome. I'm sure we do. I think there are a couple questions. I don't know if Blake can jump on and wrangle those, and I'll just get some back end things going here.
Yeah. Hey, Pat, do you mind turning my video back on?
Oh, yep. Yeah, you got it.
Thanks, bud. All right. Thank you. Don, thank you so much. I appreciate some of the refresher and also some of the new information.
For some reason I'm not hearing you now. There we go.
Sorry, is that coming through?
Yep, got you now.
There we go. Yeah, I was just, that last statement was just, just kind of sharing how much we appreciate the science and how well it was explained. So a couple questions we have so far. First one from Drew. How does ski patrol mitigate avalanche danger, and have practices changed in the Tetons since the 2008 case study that resulted in 70 or over 70 avalanches?
It's a bigger question, but there is a trend that to more remote avalanche control systems. So the head wall used to be almost exclusively triggered by hand-thrown explosives. But even in that year, they had some gas exploders in that start zone, and they on the first round, that was a really sensitive day. And on the first round, they had so many avalanches that they decided to keep the mountain closed to the public, and they were going around for another round. And it was actually the sweep crew up at the top of the head wall that put a air blast in that brought in the avalanche that hit the restaurant. That was a unique situation, I would say. There is generally a trend to more remote avalanche control systems, more bomb tram delivery systems. So things are changing, but not that rapidly. The 70 avalanches that I talked about were predominantly backcountry based, but there were certainly a lot of avalanches inbounds as well, and certainly after that day as well. So things haven't changed that much. I think the things they did in that particular instance is they moved the entrance to the ski patrol room from the uphill side of the building to the downhill side, because there was actually a ski patroller and his dog, search dog, trapped in that room that they had to break out with a sawzall from inside wall. Yeah, that one was a little more of a surprise. The one that occurred several days earlier, the response to that was very coordinated, and the response to the second one, because it didn't involve some of their own, was a little more disorganized. But in general, I would say the mitigation in the Tetons and around the West is very, very effective, and it's getting better every year.
Excellent, thank you. All right, and our second question here, and some compliments. Hey Don, great presentation, greetings from Canada. Excellent. Skier compaction. Boot packing in early season shallow snowpack before the resort opens is pretty usual. What's to stop the same faceting depth tour from restarting and carrying on all season? Is it worth the effort to stomp the slope if the problem will likely reform by spring?
So that's a good question. The boot packing programs and mechanized compaction programs in Colorado are very effective. Boot packing is very labor intensive. A lot of people call it ski patrol fat camp for the early season, but it's basically, it needs to be very, you're basically compacting all the snow, hopefully before it's even starting to facet very much. But the trick is, in steeper terrain, you need a certain amount of snow to be able to move around that terrain safely. Otherwise, you're just basically on high angle scree and rock. So there's kind of that fine balance. If it comes in too fast before you get to boot packing, you may not be affecting the weakest layers on the ground. If you've boot packed early in the season, a snowpack gets to a meter or more, that's not going to turn into facets and depth where on the bottom of the snowpack. So in general, well done boot packing is a very effective countermeasure to avalanches later in the season.
Excellent, thank you. And Pat, do we have time for one more? Okay. This is from Jeremy. I ride a fair amount of slide paths that start the year as ice climbing routes before the snow fills in. I assume this ice is very thick. Would this layer behave like a crust? And what should I look out for?
Yeah, that's a really good question. And I pondered that myself when I was caretaking up there and working for the AMC. So that's a tough one. Sometimes you're still getting water flow over the flow as it's still covered with ice. Sometimes it's just underneath. So it's a trickier one to assess. Typically that ice is going to be much colder than the ground surface at 0. So it's not going to have as much of a profound temperature gradient as you would see if that was it was thinner. And there's certainly no vapor transfer coming. Well, I won't say that, actually. That's wrong. I would say that your best assessment is when you have thin snow, say less than a meter, is digging down and doing some stability tests on that ice to snow interface. And definitely, if it's shallower, doing some hand shears and seeing if it's coming off cleanly. Are the crystals that are sitting on that ice bouncy facets versus sticky wet snow? That will help you determine that. But I can't point you to any papers or any reading where it says, oh yeah, this is what you do when you're skiing an ice climb. And having done that a bit back when I was there, it's a concern. It's like, how well is it bonded? It's one that you can't assume it's worth checking out. I'd say when you're getting to more than a meter, it's unlikely you're going to dig out your shovel and check it out. And then you're kind of counting on the bridging between the walls of the gully to hold that slab in. But I think when it gets that thick, you're generally more concerned with wind slabs or sloughs coming over the top, knocking you off, than you are about the bond to the ice itself. So how is that for a non-answer?
Well, I appreciated it. Frank or Joe, Pat, anything to add?
I would just say that was great for Don to bring it home and talk about some of this facet crust combo that we do see here regularly, and I'll give him ditto for the read lots of forecasts, because we do have such spatial variability in the effect of these facet crust combos, where they get buried deeply right at the base of the head wall, and then they're shallow at the exit from the chute on the right side, right? Like, just from place to place, they have a widely varying degree from totally benign, not reactive, to that could be the trigger point that kills you. So just keep up with that. Keep up with the forecast, keep up with those weather conditions that Don talked about, and that, these things create so much uncertainty that the second thing is ski with a partner. Travel safe, one at a time.
All right.
Awesome. Well, thanks again, Don. And we really enjoy having you. It's not my first time seeing you present at an ESA, and I always learn quite a bit. So thanks a lot for coming out.
Great. Thanks. I'll see you on Thursday.
Awesome. Before we move on to Doug Workman's presentation, we'd like to do a quick raffle giveaway, which we're psyched about. We're going to do one now, and then we're going to do one at the end of Doug's presentation. So now one of our sponsors is Hillary McCloy, who runs a physical therapy and private coaching practice here in Jackson, New Hampshire. She's helped me through a couple injuries and a surgery. And she's also a great coach for endurance sports. And has donated a subscription to her Powder Hour, which is a pre-ski season workout program. So we're psyched to have this and give this away to somebody. So without further ado, quick drum roll. Gabrielle Luciano is our winner for that. So congrats, Gabrielle. Enjoy your preseason workout with Hillary. Should be amazing. And we have your email information, so we'll send that out to you. Okay, next up, I'm going to try and explain and simultaneously bring up our next speaker, Doug Workman, who is a longtime ski guide and avalanche educator, and has, I believe, still works continuously for Jackson Hole Mountain Guides and Valdez Heli Ski Guides. And we're super psyched to have him talk about beacon search strategies tonight. Give me 1 second, please. Hey, Doug, welcome. Feel free to get your screen share going, and we can get started here.
Is the screen share working? I can't tell.
Yeah, it looks great from my end.
Cool. All right. Well, thanks, Patrick, and everybody else out there in ESA for inviting me. Again, my name is Doug Workman, and I have been a ski guide for quite a while, based in Jackson, and worked actually for quite a long time up in Valdez with Don Sharaf. And I also work with Mammoth North America. And a lot of what I do is train professional groups like search and rescue groups and ski patrols and guide services in what we at Mammut consider best practices for beacon search. And a lot of this is likely to be review for folks, but just some background. You know, obviously, I think most people know that have used a beacon, that a single target digital search with any brand of beacon, any brand of modern beacon, tends to be a fairly simple task. And once you start asking rescuers to search for multiple targets or deep targets, or search in difficult zones or areas like more industrial areas like ski areas or roadways with potential electrical interference, those searches can get more difficult. And originally, when I would go around to these groups, ski patrols and search and rescue groups and whatnot, I spent a significant amount of my time practicing the most advanced techniques for honestly the most unlikely yet complex scenarios possible. And while I still very much believe that those skill sets should be mastered by the professional user group, one of the things I noticed is that even amongst these very well-trained professional users, there was some fairly simple things, commonalities. I don't want to even call them mistakes, but things that clearly people could do better. And not only that, these were things that I think we all think that we're all doing. And I think one of the likely culprits behind this is that digital beacon searching is generally so easy that many of us don't feel that we need to practice. And I also think I've learned along the way some things we can do when we are practicing that are very specific. So when you go about your practice, rather than saying, I'm going to practice a beacon search, really asking yourself specifically, what parts of the beacon search are you practicing? So I use this airplane metaphor that you see on the screen a lot, and I use it for entry-level rescuers, and I use it for professional rescuers, because there is it lays the groundwork, first of all, for what everybody should be doing, and it also gives us good cues for some of the more advanced techniques. So I have not asked Patrick or Frank or Blake or any of the other people who have easy access to speak with me, but I'm thinking it might be easier for me to incorporate them into this than ask questions of the greater group. But we clearly can do that as well. So if anybody does want to participate through the chat, I'll just open that window and make sure that is visible. So what I'd like to do is just start out by talking about each phase of the search, the signal search, the coarse search, and the fine search, and just talk about what are the core principles of how you perform each of those sections of search. And there's no wrong answers. Feel free to throw stuff out there, but I'd like to start by just asking Patrick or Frank or Blake or anybody else, if you were to teach your friend who was new to doing a beacon search, what are the core principles that you would want to impart on that person so that they hopefully could do a satisfactory signal search? So specifically, just the phase of the search when you are searching for the signal.
Yeah, so for me, I'm thinking about starting really broad before I'm working into something narrow. So I'm looking visually at whatever my path is and identifying kind of some of those boundaries. And then I might be thinking about, being able to rule out areas without missing any geographical areas as I'm going through my signal acquisition. I'll let Blake take it from there.
Yeah, and just to make sure that I'm understanding the question correctly, so we've already gone through the initial steps and now we're actively trying to find the signal and we have not transitioned into a core search yet.
Correct. Yeah, you've turned your beacon to search and you do not have a signal. So by definition, you're searching for a signal and you're just trying to train your friend and, you know, in a short, you know, 10-minute little briefing on how they would perform that, how they interact with their beacon, how they hold their beacon, what they're looking for and whatnot.
Yeah, I mean, I think obviously I would second, you know, what Pat just said about identifying your boundaries. I think one of the things that I noticed in our terrain is that people tend to move really quickly through that signal search, so much so that they kind of bypass either clues or really where the signal is actually being picked up to begin with. So I kind of, and I like the airplane analogy that getting it off the ground and on the ground is probably the hardest part. So at the beginning here, to really just remember to move slowly as is reasonable in order to get that signal search and to make sure that you have your head up looking for, as Pat said, any more obvious clues, i.e. somebody on top of the snow.
So Pat and Blake both said a couple things that I want to just capitalize on. Somebody used the word visual. Somebody else said keeping your head up. It's really worth, you know, and interestingly, I think when most people practice searching, they practice in such a small area that when they turn the beacon to search, they instantly acquire a signal. So I don't really think actually that many people actually train in signal search. And again, I think people frequently think, well, that stage is pretty easy, so it doesn't really warrant the training that maybe another part of the search gives. But you said some really important things that I also think get overlooked. We all know that, with screens, it's very challenging for us not to always be staring at them. And I was doing a training with Aspen Highland Ski Patrol once, and I watched a ski patrolman turn their beacon to search, and they did not have a signal, and they put the beacon in their pocket. They put it away and continued down the path. And this was kind of an interesting moment for me, because my first thought was, what are you doing? Why are you putting your beacon away? But it actually really impressed on me something that I think gets overlooked, that you both stated, is that this is a visual search. This is something that you need to be doing with your eyes. You need to keep your head up. The vast majority of people that are caught and carried in avalanches are not fully buried. And it's really important to remember that but far and away, most people that you're ever going to search for at this stage are going to be found with your eyeballs. So if you're not looking with your eyes, if you're not performing the signal search primarily with your eyes, then you're really not focusing on what matters. At this point of the search, the beacon has arguably no information to give you. It has no audible sound of any significance, and there is nothing on the screen of any significance. There is no reason to be looking at it. And while I'm not sure that I would agree with it, that I would just put the beacon away, it is, if you ever try that, it really impresses upon you in a visceral way that this section of the search is going to be done just with you, no technology. So we really encourage people to get that beacon out from in front of their face. Unfortunately, we still see large numbers of people looking at the beacon, and it is very possible that they're going to miss a leg or an arm or a body part or a clue if they're staring at their screen. So we generally advise people to hold it up at their ear so that when signal acquisition does occur and your beacon does give you a sound at that point, that you're not going to miss that. So that to me is a critical piece, is do not look at your beacon. Search the terrain with your eyes. And again, we advise putting it up here just so that it's closer to your ear. So there's some other stuff that, some other kind of core principles of the signal search that have not been mentioned. Now, what should the rescuer do in terms of how they move down the slope? So as the metaphor shows, a plane that's at altitude traveling across a continent, you can be moving very fast. If you don't have a signal yet, that it means by default you're very far away. And the most important thing at that point is that you're moving fast and that you're running in a pattern that ensures that you're searching that entire area. So what types of patterns might you run to ensure that? And with what types of parameters, what types of distances? Anybody, Frank or anybody else?
I think sometimes the answer depends on the path characteristic. What's the shape of it? How big is it? A lot of times you're going to see some sort of a zigzag. You're going to see some sort of a more right angle box situation. And the key there is that when you're making those turns, so when you're going to change direction, you want to have confidence that when you do change direction, that the length of your beacon signal is going to overlap with kind of the next turn you're going to make, and that way you're not going to miss an area, if that makes sense.
Okay, so what I'm going to latch onto there, Patrick, is you said the length of your search area. What I'm searching for here is what is the range of your beacon. And it's a really critical thing. And I've noticed that when I get large groups of people who have all received a lot of training, a lot of people don't know what the range of the beacon is. And part of the thing that makes that tough is that different manufacturers and different models even have different ranges. But it's super critical that you understand the performance of your beacon. Okay. So you need to know the range, and you also need to know what all manufacturers refer to as the recommended search strip width, which is the distance between your zig and zag. It's obviously based on range. And it's important to understand how those manufacturers come to that recommended search strip width, because among other things, you need to be able to trust it. Okay, so it's worth noting that beacons have a best coupling, which tends to be when the long antennas are in line or parallel. And you have a worst possible coupling when those antennas are perpendicular. Okay, so with even a very old analog beacon, this is an Ortovox F1, you had a recommended search strip width of 80 meters. With the Mammoth Varivox S, you've got a recommended search strip width of 70 meters. And how all manufacturers arrive at that recommendation is based on the worst possible coupling, the perpendicular coupling, and the worst possible range. So with this modern beacon, you have a range that could be up to 70 meters or even more in an analog setting. And in its worst set coupling, that may only be 35 meters. And so it's important to recognize that your recommended search strip width tends to be double the range in your worst coupling. Okay, because to use the zigzag that's shown in the screen icon in under signal search there, you are essentially searching 35 meters below you when you're doing your zigzag, and then you're achieving 35 meters above you when you're below the zigzag, which ensures that you're searching the whole thing. And obviously that is effective even in worst coupling 100% of the time, which is extremely unlikely to be. So meaning that there's a lot of margin built into this, and you're certainly searching that entire area if you're doing a zigzag with this particular beacon with its recommended search strip width of 70. Now, frequently people will just throw out the random number when I ask them what is the search strip width of 40. Okay, that's just like this generic number that gets taught. Okay, and my point here is that if you are underutilizing the technology in your hand, which a lot of people do, then you are moving inefficiently, and you're searching much more thoroughly than is necessary, which in a small avalanche is not necessarily critical. But if you are unfortunate enough to search for a large avalanche, or be in a situation where you're understaffed, under-resourced, you want to be able to use the technology in hand to its full capability. But clearly, the worst thing to do, which I've watched several professionals do, is run a pattern that is too wide, thereby missing the target altogether. And again, that tends to be something that's thought of as being so simple that we don't practice. And maybe you even know what the range of your beacon is quantitatively, like you may have read the manual, you know that the recommended search strip width is 70 meters. But what does that actually look like in a piece of terrain? So it's essential, I think, that you go out and you look at it. You examine the range of your beacon and you visually figure out what does that look like and what is that going to feel like on a 35-degree slope while managing hard slab debris or broken trees. Okay, so these are simple things that people can do to refine their search and become better searchers. That again, what I've found is that even professional users are not training themselves to do. And it's just some low-hanging fruit for all of us, regardless of your level of experience, to become a better rescuer. And the only other thing that I would say there again is speed, speed, speed. Making sure that there's no way you can pass the target, miss the target, and end up at the bottom of a 1,000-foot bowl or couloir beneath them. Okay, but fairly simple. Does anybody have any questions there with signal search, or anything that is different what they would have expected, or contrary to what they've learned? Or all right, then I'm going to move on. So course search. I don't know if I have the ability to call on people, but the next name on my screen is Frank. So I'm going to ask Frank, how do you teach course search to your buddy? Okay, I'll go to the next name. What about Joe? No? All right, back to the top. Pat, how do you teach?
I'm back with you, Doug.
Okay.
It takes me a second to figure out which mute button's working. Yeah, with the course search, I teach my buddy to ignore the arrows, make the numbers get smaller.
Okay.
Simple,
I like how you sorry, I interrupted. I like how you prioritized the number over the arrow. It's very important that we all think about and recognize that your beacon, regardless of brand or model, your beacon communicates to you in 3 different ways. Your beacon has an audible tone, your beacon has a direction arrow, and your beacon has a distance indicator. And as Frank said, the number is far and away the most important piece of the equation here. If you had to teach somebody in under a minute, the simple way to do it is say, make the number go down, right? And the arrow is a tool that helps, a clue in terms of where the beacon thinks you should be moving. But I think what Frank was saying, he said, ignore the arrow. I'm not sure that I ignore it altogether, but it is important to recognize that arrow, again, with any brand of beacon, can be 180 degrees wrong because of the way radio signals work. And if the arrow is sending you in a direction where the number is starting to go up, then you should simply turn around 180 degrees and the arrow is very likely to correct. So number is the most important. The direction indicator is maybe the next important. And I would say that the tone is the least important. And for the older people in the audience, that might be hard to understand or believe, because with an older analog beacon, the sound was the single most important piece of the puzzle. But it's really important to recognize here that with digital beacons, the sound is really nothing more than encouragement. We could all go into to a sound lab and say, well, what do we want the sound to be when we acquire the signal? And someone might say, I want fireworks. Okay, great. We're going to go with fireworks. And then, what's it going to sound like when you're at a great distance? Okay, low, long tones. And then as you get closer, you're going to increase the cadence, increase the pitch. Those are all things that encourage the user. They may allow the user to look at the screen a little bit less, which is an added bonus. But generally speaking, they're telling you what you should already know because you have the number. So clearly, this stage of the search, which starts when you acquire a signal and ends when your beacon reverts into its fine search mode, is clearly the easiest part of the search, right? It's the hardest one to mess up. And because of that, there aren't a lot of notable tips. But what I do tell people is when you're far away, we want you following the arrow, making sure the number goes down, but we don't really care if the arrow is perfectly centered or not. Okay, if the arrow, as it shows in this image, is slightly off to the left or the right when you're at 50 or even 40, we don't really care. We just want you moving really quickly, and we want that number going down. But there is a point, because the closer you get, the more accuracy is going to begin to trump speed in terms of priority. There is a point during the course search where accuracy takes a heightened importance. And that number for us is 10. And we teach people that when you are at 10, you're now like the pilot who can see the airport. And now you really need to make sure that you're lined up. So we do teach that below 10, we want you to pay a lot of attention to that arrow, and we want it dead center. Some things we haven't mentioned is that we're teaching people to hold the beacon at their waist and hold it at an arm's length. Any ideas as to why we would want it at arm's length? An arm's length away from your body. That's to keep it as far away as possible from any electronics that are on your body. Unfortunately, electrical interference continues to become a bigger and bigger problem as we're carrying around essentially computers for our phones, and people have lots of Bluetooth. It is important to recognize that it is not sufficient to put your phone in airplane mode. That does not solve the problem at all. I can even demonstrate to you how a phone, when turned off, if it's in close enough proximity to the beacon, it will still create interference, as will any piece of metal. So we hold it at arm's length to make sure it's far away from our radios and our cameras and our phones. But then back to this magic spot of 10. Why below 10 do we really care that that arrow is super centered? And the reason is that the next part of the search, the fine search, is arguably the most difficult part of the search that exists. It is the part of the search that requires the most skill. And so we want to talk about that. And we want to reduce the amount of fine searching that anybody is ever doing. And we do that by keeping our arrow centered from 10 and onwards during course search, to ensure that when your beacon switches into whatever it's going to do during fine search, that you are that much closer to the victim, okay? And I believe that we as a community, whether you've been an Avalanche educator, when I think of the Avalanche courses I've taken, when I think of the Avalanche courses I've taught, there's only been one time, really, when I was trained to search for life-size targets. And that was actually when I was a student at Knowles doing drills that Don Sharaf set up. And he would always bury 6-foot-long duffel bags. And why don't we typically see that in Avalanche education? And the reason is simply that we're lazy. It's difficult, it's arduous, and it's time consuming to set up drills with life-size targets. So as a result, maybe if you're out with your buddies, sometimes you throw a beacon in a glove, or maybe you put it in a small piece of Tupperware, or maybe you actually bury a backpack, which is larger, but still not a realistic life-size target. Guide exams in Canada are 30 centimeter by 30 centimeter strike plates. Those are still very unrealistically small. They just this year, I believe, at the American Mountain Guides Association, increased the strike plate size to 45 centimeters by 45 centimeters, which is larger, but is still not anywhere close to a life-size target. And I bring this up because of the saying, and I'm probably going to butcher it, that they have in the military, where fight like you train, and train because you're going to, train like you fight because you're going to fight like you train. And I very much believe that by searching for unrealistically small targets, we have trained ourselves to search in a way that is not optimized. So some of the things that you typically see. So first of all, during course search, to back up a little bit, we talked about how you're intentionally turning the axis of your beacon so that the arrow is centered. You're holding it at waist level and intentionally turning the axis of that beacon. Well, again, regardless of the brand of the beacon, the common practice, the best practice whenever you get to fine search, which is generally about 3 meters, is whatever axis you've come in on, that beacon is to remain in that axis. Okay. What else gets taught in terms of how you do the fine search? Somebody throw something out there.
Can I just throw out a question from the audience to you, Doug?
Yes, please.
So one of them was, you answered, I think, about the effect of signal interference with cell phone, but also somebody was asking more specifically about emergency beacons, like a spot or a inReach or something like that.
Yeah, it's a really simple answer. Just go back to metal. Anything that is metal has an electromagnetic field around it. And that electromagnetic field sounds to a listening device like static, just like white noise, hissing. The more severe the static, the louder it gets. And at some point, it gets so loud that it overcomes the volume of the beep coming from the beacon. Okay, the white noise basically just obscures the sound, and you've got this listening device that you're trying to use for this rescue, and it simply cannot hear the beeps, even though they're out there, because the static noise is so loud. So a lot of beacons now have warnings when they can hear that static. I frequently carry my beacon in my pocket, kind of near my abdomen and groin. And if I get on a ski lift, it quickly starts screaming at me and says, 457 error. That's just an electrical interference indicator. Or the new Verivox S has an icon that has, a phone with a line through it. Okay. So there's a lot of beacons out there that can identify when electrical interference is happening so that you can adjust your search techniques. But the simplest thing is to move away from the offensive device, create distance, which is why during course search, we're telling you hold your beacon at arm's length, because we strongly suspect you have an iPhone or a VHF radio or some other potentially offensive device. There are situations where you cannot move away from the offending device. For example, if you're performing a rescue in bounds and there's a lift tower or a chair lift in the avalanche debris, well, you're not going to be able to just move away from it. And there are techniques in place that can help you effectively deal with that, namely just increasing the resolution of your pattern, meaning either if you're in signal search, narrow or zigzags, and that forces you to get closer to the target at the expense of what would normally be considered efficiency, right? So you're accepting the fact that I'm going to run a tighter pattern, which will increase, force me to get closer to the target, which will make it essentially louder to hopefully overcome that noise. But obviously, with the, there are actually no papers that I have ever seen that compare the potential for electrical interference between different types of electronics, but there's not a doubt in my mind that a Spot or a Garmin or an InReach, simply because it is electronic, it has an electromagnetic field, that it has the potential to create electrical interference or white noise that can get in the way of a search. Generally speaking, if you have 50 centimeters of distance between your searching beacon and your offending device, it should be more than enough to separate and clarify that search. If you were buried in an avalanche, you would very hopefully have a minimum of 20 centimeters between your beacon, which is sending a signal, and any potential offensive device. So you really do want to think about where are you putting your iPhone, where are you putting your radio, and in what sorts of positions could you get buried? Because if those devices ever were with, closer than 20 centimeters in a burial position, you could be very difficult to find. Did that answer the question about the Garmin?
Yeah, sounded good to me.
So just to backtrack a little, we know that find search is difficult. We know that if you watch a lot of professionals doing find search, they don't do it nearly as methodically as you would think. Partly because it's just difficult to move through real avalanche debris on a real slope. And even though we teach and know to keep your beacon in a fixed axis and to keep it at the same distance above the snow and to move slowly, it's just difficult to do those things in actuality. Okay, so we very much want to reduce the amount of find searching that is required. Okay, so below 10, we keep that arrow really pinpoint. Okay, and now you're in find search, you're keeping your beacon in a fixed axis. What else do we teach people at that point? Okay, the two things that you commonly hear are get down on the snow surface and move really slowly. And I just want to talk about that a little bit because I would argue that there is a slightly better way to do it. You very frequently will hear people say, get down on the snow. And by doing that, you have maybe gotten an additional, let's say, as compared to just holding the beacon at your knee, you've gotten yourself 15, 20 centimeters closer to the snow surface. Not very much. So you get a little closer to the snow surface and the target. And now you see some people virtually crawling over or severely hunched over on the snow, making it very difficult to move. You're not in a very ambulatory position. Okay, and you've only achieved getting 15 centimeters closer. I would say it's not worth it. Okay, we teach just get the beacon to your knee, keep it in a fixed axis, and you probably can move a half a click faster than you think. So we typically see people moving too slowly and too close to the snow surface. And I want to go back to target size and why I think that happens. And quite simply, if you're looking for a target that's very, very small and you know it, well, then accuracy is going to be incredibly important, especially if the way you've set up your drill is as it should be, is that you have to hit the target with a probe before you dig. If I had the ability to bury this tape measure that happens to be sitting on my desk, it's about smaller than a beacon. and I were to tell your team, I have buried this tape measure, and we're going to do a competition to see who can hit it first with a probe. You're not allowed to use a shovel at all. If I were to send that team off to race, I'm quite certain that what you're going to see is people in fine search moving extraordinarily slowly, extremely close to the snow surface, and they're going to do an enormous amount of grid searching, which is seen in this slide, forward, back, left, and right, paying a great amount of detail to the difference between 2.1 and 1.8. Okay. Now, compare that to how people are going to behave if I have the ability to bury an F-150 truck. And once again, I say, first one to hit it with a probe wins the competition. You win $1,000. And I send the team off racing for this F-150. I'm quite certain, and I would be surprised if anyone disagreed, that what you're going to see is no grid searching. People are going to run in on their course search, and as soon as they see a remotely low number on the screen, they're going to start probing, and they're very likely to get a probe strike without having to perform any grid searching. And clearly the F-150 is also not a realistic size target, but the moral of the metaphor there is that people need to start probing sooner. The probe is what finds the victim, not the beacon. If somebody is spending an enormous amount of time trying to figure out the difference between 1.7 and 2.0, they're wasting time. And while they're doing that, they're walking around on the snow surface even more, which, as you know, is compressing the snow underneath even more, which is going to make it that much harder to excavate the snow, which is the next step. So for many reasons, we believe people are over searching in fine search. So what we frequently teach for there's different ways to go about this, but the one universal is that below 10, we want that arrow pinned at center to increase your accuracy during the final stages of course search so that far less grid searching would be required. We then teach that when you are doing fine search, of course, you're keeping the beacon in a fixed axis. We also teach only going to the knee so that you can remain in a more ambulatory position, which also allows you to keep the beacon at a fixed distance above the snow surface, even if you have to step over a tree trunk or a large piece of hard debris. It's much easier to keep that level. And I think if people start training for realistic size targets, you'll find that you can probably move faster in that stage of the search than you would think. You're still moving slower relative to the speed of during course search or signal search, but I think most that you'll find if you play with target size, that you can probably be moving faster than you think. And then for the maybe call them recreational users, certainly for somebody who really doesn't practice this stuff very frequently, we would argue that it's probably good enough to find the lowest number on that single first fixed axis and just start probing from there, knowing that you might have to do 3 rotations of your spiral of probing instead of 2, okay? But it's far easier to teach someone how to be a good prober than a good grid searcher. That's a skill set that requires much more practice and much more methodology. So it looks like you have a question, Blake.
Yeah, Doug, I really appreciate the emphasis on how important that getting to that stage of probing is. So we've been looking through the lens of a single searcher. if during that core search, I have, let's say, one, perhaps even two other partners that are with me, they were part of that signal acquisition. Now, one person, likely all three beacons are probably going to pick the signal at the same time. How might I expedite that search at the end for a probe strike in that core search phase?
So I think what you're asking is how to maximize multiple rescuers to search for multiple targets. Is that fair?
That would be yes.
And I don't have a boxed answer for that, so I'm thinking a little bit, but I mean, I think a lot of it has to do with your ability to have a map in your head for where these targets potentially are. And that comes back to knowing the technology in your hand. And, you know, they're not all the same. They don't, you know, beacons, there's a lot of different brands out there. There's a lot of different models out there, and they all kind of come at it a different angle. If you're using a beacon that has a marking function, there is a chance that that beacon also has a scrolling function. So any beacon that has a marking function is based on technology that involves signal separation algorithms, which is a fancy way of just saying that it's figured out how many targets are out there and which one is generally the closest and which one is generally the farthest away. And because that tends to be a fairly simple in practice to use a beacon with marking, people think that it's fairly simple, but it's actually a very large lift for a beacon. The easiest example of what I think you're asking the beacon to do when you're asking it to separate all those signals is, imagine walking into the entryway of your favorite tavern in North Conway, and with your back to the bar, you have to tell me how many people are in the bar and who is the closest to you and who is the furthest away. And then you have to hone in on the closest one and only listen to that one and tell me what that person's talking about. Okay, so there's a lot of noise, and the beacon is being asked to, you know, separate a lot of information. If your beacon has the ability, gives you a list of buried subjects, you may also have the ability to scroll through those and confirm that your beacon is going to the closest victim. That can also help you figure out if the victims that you're headed to are close together or not. If they're not close together, then you might be able to tell a different searcher, hey, you know, I'm 7 meters from this one. I'm going this way. You know, I want you to search, you know, a different quadrant of the possible burial area and see if you pick up a signal that way. That's my off the cuff answer, but essentially you're being forced to do triage by saying to the rescuer, hey, I don't want you going, just continue searching to this one that your beacon's taking you to. So you've got to force your beacon to pick up another signal by moving just in a different direction.
Awesome. Thank you.
Any other questions?
There's one here, Doug, in a similar vein from Mona. If you have a second person who can probe, so I'm guessing, you know, two rescuers, one burial. Second person who can probe, would you suggest over searching with the beacon?
Well, I'm not sure I understand what's meant by over searching.
I think the spirit of the question is, if you have two people for one burial, what's the most efficient way to use both people?
To me, and if I'm not effectively answering the question, just let me know. But to me, the thing to remember that we already just touched on is that the probe is the tool that finds the victim. So the faster you get to probing, the better. So to go back to that airplane metaphor, you know, if I have my probe out, because say I'm assisting Blake is doing the beacon search, and I have confidence in Blake's ability to do a beacon search. So I'm going to go ahead and get my probe and my shovel out and follow him. Of course, having my beacon in a setting, which is not going to make it more complicated for Blake. And then as soon as Blake is getting anywhere close to the victim, and I know that simply because of watching him and his behavior, if he's got his beacon down at his knee and he's landing the plane, then I know he's close. And I would encourage that auxiliary rescuer to be just hastily spot probing any likely areas near Blake. And I would say that there's a very good chance you're going to get a probe strike before anybody has completed any sort of fine searching. So that would be another very effective way to eliminate or reduce the amount of fine searching required, which should always be a goal.
Sweet. Another question from Kyle. If I have a berry box on the EU frequency, can I use it in North America, or do I need to reorient the frequency of the beacon?
Yes, you can definitely use it in North America. That frequency is only a subset, essentially a secondary tool that we use to wirelessly do firmware updates and change settings and do diagnostic testing on the beacons. There will be a slightly enhanced performance if you're using the correct W-Link frequency. But that performance boost would only be noticed between searching for a berry box with a berry box. If the beacon that you're searching with is in an EU W-Link setting, you will notice no difference in performance if you're searching for a different brand of beacon that is not W-Link enabled. It would essentially be like turning your W-Link off, which most beacons don't even have a W-Link. So I would say it's not overly concerning. I would say get it adjusted when you can, maximize performance, but it certainly is not like your beacon just can't be used.
Sweet. All right, message from Ken. Great food for thought on simplicity and speed, but I'm struggling with not doing the grid, especially on a deeper burial. Seems like you could end up quite a ways off target. Does it come down to just 3 versus 2 probe spirals? Not sure about that last point, but if you could speak to that.
And this was did you say Ken or Ken?
From Ken, yep.
Yeah, so Ken brought up a very important point. Yes, that would not apply for a deep burial, but I was presenting, and I should have clarified that the vast majority of burials are shallow burials, and so that technique of minimizing grid searching is effective for shallow burials. And I'm not saying never do a left or a right pass, but I'm saying for a large number of users, it's easier for them to be a good prober than to be a super effective grid searching. And I think we overemphasize the necessity of that grid searching. For a more advanced user or a user that's been able to identify that the lowest number was actually a relatively high number, anything over 2.5 would definitely be considered a deep burial, and more grid searching in that case is certainly going to be very valuable. I'd say that's a very, very good point he brought up.
Yeah, it seems like a lot of times people get kind of disassociated with the number and what it means in real life. If you have something that's half a meter or just over, in reality, that person is right there. So it kind of speaks to what you're saying. Here's a question from, what do you think about the new voice technology with OrthoVox, if you know anything about that? Somebody was wondering.
I don't know much about it. I did get to play with it this last weekend at YSAW. The OrthoVox rep, Adam Worth, was there, and he let me play with it for a little while. I think that all advances in technology are great. And anything we can do to create user interfaces that are more intuitive is great. I still stand by the fact that in terms of a priority of how your beacon is communicating with you, that the number is the most important. The direction arrow is the next most important. And any sound coming out of a digital beacon is the least important. I don't need sound at all. If someone gave me a a track or two that had a broken speaker, my ability to search would not even be remotely inhibited. I just make the number go down and follow the arrow, right? I can do grid searches. I can do more advanced techniques like 3-circle methods or micro search strips. I lose nothing when I lose digital sound because all it is encouragement. Does that mean that encouragement is not valuable? No, it just means it's not essential. So I would say that voice activation is taking encouragement to the next level, and maybe will continue to have future value, but it certainly does not change the game.
Awesome. Blake or Frank, or I'm sorry, actually, Doug, have you gone through your presentation material before I start to ask for any questions?
Yeah, I'm sorry that I only have one slide. This is a super low-tech presentation. But I think I've really hit on what I wanted to hit on in terms of just trying to get people thinking about how they can be better searchers and what common things we're all doing that maybe are not the actual best practices. So yeah, any questions would be great.
Hey, Doug, can you hear me?
I can.
Just curious if there's anything in the industry trending towards making either the audio signals or some of those functions designed to elicit certain responses from the people searching, if there's an effort towards making those universal rather than proprietary, so that people can be more fluid when going from one device to another?
There is nothing that I know about that encourages manufacturers to work together to make things more universal. And while I agree it would be easier to move from one device to the next, I tend to think it probably would also inhibit innovation if there wasn't that competition between the manufacturers. So at the end of the day, I think it's a good thing that there's competition, but I do know that it makes it more difficult. But no, I don't think there's really anything that's pushing manufacturers to create any sort of universality between the way that they're approaching these things. And the one thing I would say, what's that?
Oh, sorry. I just have a follow-up question is the audio function that's been added. What's the real driver for manufacturers to not just have analog audio of the actual signals themselves coming in? It's a function on like advanced beacons, like some of the beacons that you guys make, where you can just keep analog on. Personally, I find when I go from coarse search to fine search and I get a shrill digital beacon, I find that adding a stress level to an already stressful situation, rather than an analog signal where I can actually start listening even and possibly hear a second beacon in the fray, and kind of bypassing the digital processing. What's the driver behind that? I is it just about making it easier for folks just starting out, or?
Yeah, well, first of all, I've tried not to speak to anything that is specific to BerryBox, because I want this to be, as applicable to as many people as possible. But since you're asking, again, I think that digital audio is encouraging. And just to backtrack there on that Ortovox question about the beacon that's speaking to you, the one piece I also wanted to say is I do think it's interesting that beacon that's speaking to you is very much sounds like the way your GPS in your car sounds. That's the way it's speaking to you. And similarly, the way that the software on the BerryBox S works when you're doing this grid search, I haven't talked about it much, but you can see those icons are very similar to a GPS, where you've got that arrow on the road. And I do think that that's an interesting route that is kind of being taken by many beacon manufacturers in different ways, because the more familiar that user interface appears, and if it really does build on the familiarity we already have with GPSs, I do think that that is a cool thing that I picked up on when I saw that Ortovox. In terms of the analog sound, Barryvox has always believed since the first digital beacon that they made, which was the Opto 3000, I think in 1998, that digital technology was a game changer. It made everybody a faster searcher far and wide when BCA came out with that technology. When you start to, and it made single beacon searches so easy that very quickly manufacturers were looking at like, well, now that these single searches are so easy, we should be trying to make multiple burial searches easy as well. The problem with digital beacons that are trying to make sense of multiple burials is that when that listening device is trying to figure out how many voices do I hear, it really has to hear enough of that person speaking, so to speak, that they can identify that it's one signal. So where the human ear can hear one beep and they can instantly know that there's a signal out there, the beacon that is looking to use signal separation algorithms needs to hear more than one beep. It needs to see a pattern and hear a pattern. And the problem with that, so that's an analog signal. I don't know if you can hear that. And the second you hear that analog receiver go from silence to sound, that very millisecond, the human ear knows there's a signal there. Whereas a digital beacon that's trying to build up a list of buried subjects, it's going to want to hear several beeps, maybe 3, before it feels confident in saying there's a victim there. And because it wants to hear that it's in a rhythmic pattern and that it's all part of one thing. As soon as 2 beacons beep at the same time, which is what we refer to as signal overlap, then the beacon's ability to confidently tell you how many victims are out there is completely thrown awry. Okay, so if you think that there is any likelihood that you're dealing with that situation, then having analog tones is extremely beneficial because the human ear is so much faster at discerning that information. But that is definitely something that takes more advanced practice and skill and methodology. It's not that easy in a high pressure situation to do any form of deductive reasoning. So that's something that you definitely need to have a strategy for beforehand and practice, because just having analog sound is not enough. You're not going to be able to really figure out how to use it in conjunction with digital. But yes, Frank, the short answer to your question is that we've always believed that for the most complicated searches especially, that having analog sound in conjunction with digital distance and direction indicators and marking is far and away the most effective way to deal with the most complicated scenarios. That being said, those complicated scenarios should be rare, although they're certainly not as rare as they used to be when you look at the multiple burial scenarios going on, an increase in that. And it used to be, I think, that we could all say, oh, well, if there was a multiple burial scenario, then obviously somebody messed up so badly that you could kind of almost shame someone from even thinking about that. I, for one, know when I'm skiing a run on Teton Pass or even in the park nowadays, that it's very rare that I can say with any sort of absolute confidence that there aren't multiple people below me. And it's also very rare that I can say that there aren't people above me. The mountains have gotten really crowded really fast. And as we saw with the Ophir slide last year and the Battleship Mountain slide in Colorado, multiple burials are real. And again, most of those, especially if you're searching for modern technology, should be easily solved with a marking beacon. But there are scenarios, unfortunately, the United States, if you compare to Europe for sure, there's a lot more old technology out there that we're searching for, things like anything, I don't know, anything that's more than 10 years old. There's a lot of it out there. It makes searching more difficult. And there are times when having analog tones are incredibly valuable, but that's definitely something that takes quite a bit of skill. So yes, Frank, the reason we don't all have that is because for most people in most scenarios, having a simple digital user interface is going to benefit the most number of people.
Yep, thanks. Looks like there's another one in the Q&A chat. For the signal search phase, would you recommend a particular pattern, or is it largely dependent on the specific terrain?
Well, the pattern is,
that.
Yeah, the pattern is dependent on, the pattern itself is dependent on the number of users, number of rescuers, and the range of the beacon. So if the recommended search strip width, say this Berry box in front of me is a 70-meter search strip width, and say I've got myself and Patrick and Blake and Frank, and we're all rescuers on scene. If we can spread out 70 meters between all of us, if that's the beacon we're all using, and know that by simply walking straight down the field, the slope, that we're going to have ample coverage of that area, then that would be the pattern of choice. If you're a single rescuer and you can just walk straight down the center of the slope, and you know that your beacon has a range where you're easily going to cover the entire area, then that's certainly going to be the fastest way. The only time you need to do any kind of zigzags are when you don't have the ability to get the full width of the slope simply by walking straight down it. So, so for most single searcher scenarios, you would do a zigzag search with the recommended search strip width between your zig and your zag, and half of that recommended search strip width laterally from the sidewalls of the slide. Does that answer the question?
Yeah, I think so. And yeah, I think that was good. Anything else from, John Sidek, do you have a question? We could bring you on live if you want. Otherwise, we'll probably wrap this up in just a second here. We haven't done this yet, so I don't know if it'll work, but.
Maybe we can unmute him. John, you there still?
Do you have the ability to do that, Frank? I'm a little slow with getting to him here.
I'm not as a panelist. I don't believe I can do that.
All right, John, if you want to, you can unmute right now. If not, we'll wrap it up.
Patrick, just if you go into participants list and then click on unmute, should be able to get that from there.
Okay, he says he's all good, so. All right, anything else from, sorry about that. Anything else from any of the panelists, Frank, Blake, Joe?
Nothing here. That was great, Doug. Thanks. Thanks for the tune-up.
Thanks, everybody. Have a great, safe season.
Yeah, thank you, Doug. I appreciate it.
All right.
Doug, thanks a lot. It's great to have you. I loved that approach to teaching about beacon searching. It was very refreshing for me, and I'm sure our audience got a lot out of that. So lastly, we are going to do a quick raffle before we say goodnight to everybody. This is a big one. This one is from Acadia Mountain Guides, who is one of our big supporters over the years of ESAW and of the Avalanche Center. AMG is giving away an Airy 1 to somebody for this winter, and they'll be able to connect with the guides about that after the event. We'll connect you via email. So again, thanks to Acadia Mountain Guides, and this Airy 1 course is going to Indira Gowell, or Indira Gowell. I'm sorry if I didn't get your name right, but congratulations, and we'll put you in touch with the Acadia Mountain Guides. All right, thanks everybody for a great evening. Tomorrow night we'll be back again at 6, and we'll have Mike Austin from Avalanche Geeks presenting on a pretty crazy season in the Alps with COVID last year, and followed by Pascal Hageli talking about some social science research that's going on in the Avalanche world. So we're really excited for tomorrow night. Frank, do you have anything before we wrap it up here?
Nothing for me. Thanks for joining, everybody.
Awesome. Have a great night, everybody, and we'll see you tomorrow.